Hey everyone, and welcome to our latest explainer. Today we're serving up a rapid-fire introduction to Bragadeesh Sundararajan's really foundational book, Ultimate Data Engineering Design Patterns. If you want to know exactly how messy, raw information becomes the absolute lifeblood of modern AI, well, you are in the right place. Let's dive in. Bragadeesh hits the nail on the head right in the preface, stating, in today's digital economy, data has become one of the most valuable assets an organization can possess. We hear all the time that data is the new oil, right? But the real question is, how do we actually unlock that value? So here's our roadmap for today. We're going to cover the value of data, defining data engineering, looking at core responsibilities, exploring the data ecosystem, and then finishing up with a real-world use case. All right, part 1, the value of data, going from raw to actionable. Look, raw data is, well, it's chaotic. It's unstructured and super fragmented. You can have the most cutting-edge AI models in the world, but without clean, structured data sets to feed them, they're literally useless. And AI is really only as good as the data it gets. Moving on to part 2, defining data engineering and how we bridge that gap. So what is it exactly? Basically, data engineering is all about designing, building, and maintaining the systems that collect, process, and transform raw data into usable formats. Engineers build the pipelines that automate this whole process. They act as the vital bridge between that raw chaos we just talked about and actual, pristine insights. Section 3. Core responsibilities. What do data engineers actually do? Their day-to-day is highly technical. We're talking designing scalable architecture, ensuring the data is actually high quality and dependable, implementing governance rules like GDPR, which is absolutely crucial, and constantly optimizing processing and storage for peak performance. Now, a quick aside, don't confuse data engineering with data science. Data engineers are the architects building the infrastructure and those ETL pipelines. Data scientists, on the other hand, take that prepped data to extract insights and build machine learning models. Basically, the engineer stocks the pantry and the scientist cooks the meal. Which brings us to part 4, the data ecosystem and taking a collaborative approach. Because, no role operates in a vacuum here. Data engineers, architects, analysts, and scientists, they all overlap. It requires this deeply collaborative ecosystem to move data seamlessly from its initial ingestion all the way to a valuable business insight. Finally, part 5. Let's look at a real-world use case with an e-commerce recommender. Imagine an e-commerce company that's trying to boost sales and really enhance the customer experience. How do they do it? Well, they decide to build a smart product recommendation engine. Here's how that data journey actually plays out. Step 1. The data engineer consolidates all those raw user behavior logs using ETL pipelines, getting them into a clean warehouse. Then, step 2, the data scientist takes that beautifully clean data to train their machine learning algorithms. See? The engineer's prep work directly powers the AI's predictions. So, I'll leave you with this question to think about. Is your organization's data a highly tuned asset, or is it kind of just a chaotic liability? If you want to solve these challenges at scale, definitely check out Bragadeesh Sundararajan's Ultimate Data Engineering Design Patterns. Thanks so much for joining us for this explainer, and we'll catch you in the next